Okay, this is lesson 3 on compound interest. I'm wondering if this one's going to be a little bit challenging. You might have to watch this video more than once. So let's look at some of the things we've talked about before in Unit 2. We're looking at compound interest, and that is when interest is earned on the interest. So unlike simple interest, where you would make the same amount of interest every single year, compound interest is really exciting if it's compound interest you're earning on an investment. Because let's say you made $100 in interest in 1 year, then that goes into your principal amount that you started with, and then you're going to earn interest on the total amount the following year. So the interest grows a lot faster, and you make a lot more money than you would if it was an investment with simple interest. Unfortunately, loans and credit cards, they also charge compound interest. So the credit card company makes really good money, or somebody giving you a car loan is charging compound interest. So they're actually making more money that way as well. So it kind of is to your benefit if it's some money that you've invested. So interest is commonly calculated or compounded at regular intervals. These intervals can vary. So you might kind of remember us talking about some of these intervals. Annually just means one time a year. Semi-annually, 2 times a year. Quarterly, 4 times a year. Monthly, we've talked about 12 times a year. Semi-monthly, 24 times a year. So semi-monthly is a little like semi-annually, but semi-annually twice a year. Semi-monthly means twice a month. Weekly, 52 times because there's 52 weeks. Bi-weekly, we talked about that before. There's actually 26 pays if you were paid bi-weekly every 2 weeks. And then daily is 365 times a year. So you might have to refer back to this table a couple of times when we go through this. The compound interest formula is a little strange looking at first. So there is an exponent. We have to follow BEDMAS rules. So we would have to do what's inside the brackets first, and then find out what that is to an exponent, and then multiply what we get here by P. But we'll practice some together. What's important is the values in this formula are P, I, and N, and those are the values that we are always going to have to find in order to do the question for compound interest. So A is just the final amount that you have in the end altogether. So it doesn't just tell you the interest like simple interest, it actually gives you the final amount that you would have, including interest. So the N, the exponent N, N represents the number of times the loan is compounded over its lifetime. So N is the number of compounding time periods per year times the number of years. So for example, okay, we're going to do some of these together if it sounds confusing. Just to find this little value for this little exponent, the N, if a loan is compounded monthly, so monthly is 12 times, 12 times a year, but then for 3 years, so that's what our N would equal. N would actually equal 36 for that question. So our little exponent would have to be 36. The value of N, if a loan is compounded quarterly, quarterly is 4 times a year for 5 years. So just finding that little exponent, we would do 4 times a year for 5 years. And so we would get 20. And our little N value would be 20. Finding the I, so the I is the value that goes in here, that's 1 plus I. The value I is the interest rate. The interest rate is pretty important as well. We have always using a decimal, which we've talked about when we look at a percent. We always use a decimal. If it's 8%, we'd use 0.08. But we have to divide it by how many compounding periods there are in a year. So if we had 12% interest, for example, so if we're going to find the little I, 0.12, because we'd always want to divide our interest rate by 100. But compounded quarterly, that means if we had 12% for the year, it would have to be divided up into 4 because we're looking at quarterly interest compounding. So when we divide 0.12 by 4, we get 0.03. What's the I? If the interest rate is 8% and it's compounded semi-annually, twice a year. That's only twice a year, not twice a month. So the I here would be 0.08, but we'd have to divide it by those two different compounding periods for that year. So we would end up with 0.04. The P, that's the easy one. P is just how much you start with. That's the principal. So if $500 is borrowed, the P is just 500. So that number that goes in at the front of the formula is always just the value that you're starting with, or how much you're borrowing, or how much you're investing. So using this entire formula would give us the total, including the interest that we would make. So example 6, let's try an actual question. Johnny invests $800 that pays 8%. So I sometimes underline each thing. $800 that pays 8% compounded quarterly for 5 years. How much is the investment worth at the end of the 5 years? So on the side, I find it helps to do my little pin. So P, I, and N. So that's just an equal sign. P is how much you start with. So that's the 800. The I is the interest rate. So you'd think that's just 0.08 because I see this 8% and I'd have to divide. But it's quarterly. So I have to divide that by 4. So I get 0.02. And then the N, so that's the number of years we have, is just 5. But that's not enough either. This is just how many compounding periods there would be in total. So for 5 years, but it's compounded 4 times each year. So we'd have to multiply by 4. So it's always the same, which might help. These two, the I and the N that we find, if it's quarterly, we divide by 4, multiply by 4. If it's monthly, we divide the I by 12, we multiply the N by 12. So the I is always divide and the N is always multiply. So that's going to be something that you're going to have to be careful of. And then 5 times 4 is just 20. So now that we have our values, when we go over to our formula, equals P times 1 plus I to the N, the exponent N, we just sub in our numbers. So the principal is how much we start with. And we have 1 plus 0.02 is our interest rate. And our exponent is 20. So hopefully you have a scientific calculator. If not, you can use just Google scientific calculator. It's here. So whatever your value is inside the bracket, you would type that in, and then it's to the exponent. So if we had 1 plus 0.02, that's 1.02 to the exponent 20. I could just type in 1.02 to the exponent 20, and it would give me the answer, and you could round off to 2 decimal places. So we have 800, and I'd add these together, 1.02 to the exponent 20. If you had a nice scientific calculator, you can just type it in how you see it. 800 bracket 1.02 bracket to the exponent 20, and it'll just give you the answer. So I'm not sure if you have a calculator at home right now. So 832.32. So that means the extra 32.32 was interest. So last example, just to practice this, if we do our P and our I and our N, principal is what you start with, and that is, or what you're actually getting a loan for, that would be $1,500. The interest rate, you'd think it's 0.12 because I want to make sure that I divide this by 100. but it's compounded monthly. So I've got to divide my I by 12. And I get 0.01. I am expecting you're going to use a calculator. This would be hard without it. And then the n is, I see 3 years. So the n you'd think is 3 years, but if it's monthly, we have to multiply by 12. So we get 36. So our formula, this is as hard as it gets, but hopefully you're finding this okay. Our formula would be p times 1 plus I to the exponent n. And so our principal is 1500. 1 plus I is 0.01 to the exponent 36. I think this is the hardest part to remember, there and there. And then that would be 1500. When I add those together, I get 1.01 to the exponent 36. So scientific calculator, type it in exactly how you see it. 1500 bracket 1.01 bracket to the exponent 36. Or you might have to use an online scientific calculator. If you do that, I would do this number to the exponent 36, find out what that is, and then multiply it by 1500. And I get 2,146.15, which is exciting. So oh no, this was a loan. So actually the loan was for $1,500. This is how much you actually had to pay then, because you had to pay some extra interest there. You didn't just have to pay back the $1,500, you had to pay extra, right? About 7. You had to pay extra about $650 extra that was interest. So then after, there are some homework questions. Hopefully it'll be okay, and give those a try, and then I can help you definitely if you get stuck.